Hello everyone, welcome to our new video series from our YouTube channel. This video series we are going to be focusing on artificial intelligence in construction and also real estate. And particularly in this episode, our focus will be on decentralized computing. It's a bit of an overview of what's going to be covered today. In this episode, we'll start by an introduction, areas of application for artificial intelligence in both construction and also real estate as a final product of any construction project. Why this decentralization is important for us and why centralized systems are no good. Then we dive into a briefing on what is a data center, what is a CPU versus GPU, central 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 processing unit, and also graphics processing unit, and we compare them, which one has more advantages over over the other one, particularly in respect to running AI algorithms. Um, so, as a bit of an introduction, tackling the construction and real estate issues, AI is revolutionizing the industry by enhancing project planning, safety monitoring, and cost estimation in construction. And on the other side, in the real estate realm, while driving a smarter property valuation, market forecasting, and customer experience in real estate, it ultimately creates a safer and more efficient, plus more profitable outcome for the investors in the real estate industry. It's a loop. So we have developers who act as real estate agents. It's a circular economy. Real estate developer or developer real estate construction, and it solves the housing issue. Um, Areas of application for artificial intelligence, if we divide them into construction and real estate. For construction, possible areas of application, it will be project planning, scheduling, design optimization, safety monitoring, equipment and predictive maintenance, drones and site monitoring, site inspection, quality controls, you may want to as well say, waste management, and cost estimation. So, one of the active research projects at the Institute is the implementation of object detection in quality inspection for the building projects, where we're deploying cameras on building projects to find out where the defects are. That will require an algorithm to receive videographs and also detect any defects that may be existing on the building project. So there's a lot of computing demand in that program. Therefore, we need something reliable and also fast for processing all those sort of data that is being received. On the other side, when we are focusing on the applications of artificial intelligence in real estate, some of the key aspects would be important for us, such as property valuation, market forecasting, smart property search, customer service and virtual assistant, fraud detection, virtual tours and staging, energy efficiency, and smart buildings. So that would fall under strata management as well. So imagine a multi-story residential building that, as a strata manager, you're able to reduce the energy consumption of that building by deploying smart devices such as sensors. When there's nobody in a parking, there is no need for the lights to be on, and so on and so forth. So there are so many areas that can be studied. But why do we care about decentralization when it comes to AI and, say, blockchain? So there are three main problems currently that decentralization address. Um, so first problem will be the security. There are currently centralized AI services like those hosted by a few big tech companies that create a single point of failure and these are targets for hackers. Sensitive data used for training or inference can be exposed or misused if everything is collected in one place. So, how decentralized AI help um, tackling security issue is by the fact that data and computation are distributed across many nodes, reducing risks of mass data breaches, and also users can retain ownership of their data and interact with AI models securely, often using cryptographic um, proofs to ensure the integrity. The other problem number two is the reliability. So centralized platforms rely on limited infrastructure. If a data center fails for any environmental reason, let's say an earthquake, flooding, or any kind of problem that can damage the building, the infrastructure of the data center, um, the outage can disrupt thousands of services and users, and this is not something really pleasant. You want your system to be accessible 24/7 anytime someone wants to get access, and particularly if those information are critical. How decentralized AI help? It helps by spreading workload across a distributed network of GPUs, let's say, and computing nodes. Decentralized AI avoids single point of failure. If one node goes off, other take over, and it will create a more resilient AI infrastructure. Problem number three is autocracy. A handful of corruptions currently dominating AI development. This raises concerns about monopolistic control, biased AI models, censorship, and gatekeeping of access. How decentralized AI helps is that its decision making and resource allocation are governed by communities or token based system, not a single entity. This democratized access, allowing developers, researchers, and smaller businesses to participate in training and running models. So, yeah, decentralizations would address all these three issues, and it is why it is really important for us. A data center, what is a data center? Is based on three key factors. One part is a software part, which we call it HTTP. Let's say this is the language that the client and the server communicate. A client is, let's say, is yourself when you're sitting behind your computer browsing the internet. You are communicating with the server, with the data center, through HTTP language. So your computer and the computers in a data center, they communicate through HTTP language. The website, it is composed of three, the HTTP language, any request, let's say, is composed of three sections. Is the first one is the header, second one is the meta, and the body. Body is where your website, let's say, if you're running a website, body of the HTTP language is where you put all the HTML, JSON, PHP, all those files, images that your website has. And upon requesting with HTTP language from the server, you will receive the website on your browser. So it has a get function. So let's say it says get the IP address. So you're pointing at a place in a data center, and then it brings out all the folders that contains the information on that particular website. Server, a web server is both the software that processes HTTP requests and delivers web content to users such as Apache or NGINX, and the hardware, a physical machine with CPUs and GPUs, memory, storage, and network that hosts this software and makes website and application accessible over the internet. So, if you look at it in a smaller scale, even your laptop can be a data center. You can turn off your turn off your firewall, and all the security measures on your laptop and connect it to the public. Let everyone access the data that you have on your laptop. That will become a really small and limited data center. Latency is the time that it takes from a user, a client, and a server to talk to each other. Lower latency, the more desirable that platform will be. So that's another key important aspect of having GPUs and CPUs compared. So next, we're going to compare CPUs and GPUs. CPUs are composed of just few cores. So on your laptop, for example, you will see Intel Core i4 or Intel Core i6. The more the number of those cores, it means that the more functionality you can get out of that laptop or computer. Versus GPUs, there are thousands of cores. Each core has limited type of abilities, but altogether it would create a more powerful computing unit. So the purpose of a CPU will be a general purpose processor. It's the brain of a computer. The architecture is just a few cores, commonly between 4 to 16 in consumer PCs, more in servers, and it's optimized for sequential processing. So it's really good to get from point A to point B where there are 1,000 other steps in between involved. And the strengths of using a CPU will be it's excellent at handling diverse tasks. So you may have thousands of different tasks that are sequential. CPUs are perfect for them. Versus in a GPU, cores are really skilled and equipped with just only a limited amount of ability. But altogether, all of those 1,000 cores together, they will build a huge and more efficient machine. So if you like a fast response from a unit, it is better to go ahead with a GPU. But if you like to have like the timing doesn't matter to you and you have a limited amount of computing to be handled, CPU is just the best and more economical option to go ahead with. Another strength for the CPU is that it is optimized for low latency performance, responding quickly to single tasks. On the other side, we have the purpose for GPU, which is originally designed for rendering graphics and used for parallel computing for AI simulation and scientific tasks. Um, so imagine that there are hundreds of, so we'll keep that for the next video, next slide, as a kitchen analogy to compare the CPU and GPU more sensible. And the strength of the GPU will be they are excellent at doing the same operation on a larger scale repetitively and are optimized for high throughput rather than low latency. So we have a really interesting analogy. We call it kitchen example to compare the sequential versus massive parallel and repetitive tasks. A CPU is a head chef in a restaurant. Imagine a head chef in a kitchen. They are highly skilled and can cook any dish and make quick decision about what to do next, but they can only handle a few dishes at a time. If you ask them to prepare 100 identical sandwiches, um, they will do it very well, but it will take a while because they have to make them mostly one after another. A GPU, on the other hand, is a team of many line cooks. So now imagine a kitchen with hundreds of line cooks that are trained to make just sandwiches. You give them bread, cheese, and ham, and they will make a sandwich come out almost at the same time. They are not as flexible as a head chef, and they are not good in handling great complex tasks. So if you have 100 clients at the same time approaching your server, it is better to have a GPU because all 100 people, all 100 requests can be addressed at the same time, having a GPU, but a CPU may take longer time to answer all of the 100 requests because it might not be just suitable to address 100 requests at the same time. But if you ask a GPU to make pizza as well, then the GPU might fail, whereas the CPU will be still up and running even with making a pizza rather than just a sandwich. So this is going to be a run through about one of the GPU rigs that was made back in 2019. As you may be able to see, there are three MSI GPUs, and it was formerly connected to the Vertcoin blockchain network. And just to show you how powerful it used to be back in those days, you would have to just plug it into the wall as a electricity supply, and it would generate $100 per week back then. But as the computing powers started to grow, more servers like this were connected to the network. This little machine started to get paid less than what it used to, and after a while, it just became redundant, considering that how much electricity it consumes to run and how much money it was actually generating. So it was to a point that I was about to get more and more of these GPUs connected to keep the um, profitability at the same level, and it just became redundant. So imagine these days, this whole big module, messy and with a lot of components, is now just being compacted into small devices as small as, say, this, just like a football ball, and that would make the same amount of money as this giant machine used to make. Um, so yeah, just to run through, it had GPUs. GPUs themselves are equipped with cooling system, but very noisy as well. Like just imagine whenever these six fans, one, two, three, four, or actually more, five on the power supply, and the other one on the CPU. All of them at the same time were running, and it was just super noisy. Couldn't sleep at night. But anyway, since you're connecting three GPUs to the motherboard, it has a motherboard. We're gonna need to have a converter. That is a converter, and it connects everything to where the GPUs are getting their responses. It has a RAM, as you may see here. CPU is under the fan, a sophisticated power supply, and it was running on a Windows system. One of the key points that was brought to attention when this was connected to a network was that the Windows firewall had to be turned on in order to um, let the network access all the potentials of these GPU. So it was a GPU miner, whereas and it became a data center basically once it was connected to the power and the internet via wireless. You could also connect it with a cable to the internet. It became a data center, decentralized data center for a Vertcoin blockchain. And these days, the devices are really much more compact compared to this massive, noisy, and high electricity consuming device. Similar to a normal computer, you would have a motherboard, a RAM, a CPU, also SSD. This is the SSD, I reckon it was 120 gigabytes. Yep. Um, and also to power all these GPUs, you would have to need a sophisticated power supply in order to supply the power simultaneously to all of them.